let me see.
It seems it started recording. Do you,
Oh.
everybody sees my screen now?
I can see it, so I think everybody else will see it as well.
Okay, great.
I will just mute myself, enjoy, have fun, and yeah, talk to you afterwards.
Yeah, thanks. Thank you. So welcome to this session about the circuit breaker. I am Nicolas Frankel. I've been an architect, I've been a developer, I've been a tech lead, I've been well, a lot of stuff. I always worked as a consultant, meaning that I was on customer side and doing whatever it takes to make the customer project successful. And then like since 1 year, I've been starting a new job as a developer advocate. But even when I worked in the development field, I was always interested about what happens afterwards, because you know, there is this big wall between dev and ops, the wall of shame or the wall of misunderstanding, or call it however you want. And basically what the developers want is just to ship the product, and then it's not their problem anymore. I was already interested in what happens afterwards. So I was interested in deployment automation and monitoring and stuff like that. So that's natural that right now this is a bit interesting to me, that actually I can talk about stuff like that. And I work for a company called Hazelcast, so perhaps you probably heard about Hazelcast, especially if you are in this Java ecosystem. Our old age product is Hazelcast IMDG. It's an in-memory data store. So basically we are offering you caching solution so that it's very, very fast. And recently we published a new product called Hazelcast Jet. And basically it builds on Hazelcast IMDG to offer you data streaming capabilities. But now on to our agenda. So I will have some general introduction, tell you about this problem of those microservices and how the circuit breaker pattern can help you with that. And then we will see how Istio implement the circuit breaker, or how Hystrix implement the circuit breaker. You also will be able to vote, because I have an Hystrix implementation and a Resilience 4G implementation. So this is a talk in which you can also have a voice in the matter. So I've been a developer, as I mentioned, and because of that, I'm super lazy. And I took this definition of microservices from Martin Fowler's Blicky. And basically, if you read about it, in general, everybody say, hey, that's fine. That's what we are doing. So we are doing microservices. Seems that the slides are not moving. Okay, so what can I do about it? Can somebody confirm that it doesn't work, or because I don't know what to do. I'm not used to that.
You need help?
You only see the first slide.
Yes, you have to share, start the presentation.
Again, so I will share that.
Perfect.
And now if I go afterwards, do you see it?
Yes.
Well, perfect. Sorry about that. I'm not used to Zoom stuff. So this is the definition from Martin Fowler, and everybody in general agrees with that. And when I do this talk live, I ask people, hey guys, so who is doing microservices? And in generally, 30% till 60% of the room say, yeah, we are doing microservices, because everybody is doing microservices, because microservices is hype, and you should definitely have microservices on your resume, which makes sense. However, I think that most of us don't do microservices at all, because of these stupid little bullet points here, which is that microservices are organized around business capabilities, and most organizations, they do project, they don't do product. And unfortunately, if you do projects, it's not microservices, because a project as a beginning and an end, whereas a product as a beginning, but normally, yeah, it should be like forever until it's decommissioned, but you don't know the end time. And so my take on that is that in general, you must be this tool to use microservices, and in general, this is sadly not the case. Worse, most talks or posts or whatever that I see about microservices is like taken from the technical side. And the problem is that microservices are not a technical solution to a technical problem. They are an organizational solution to an organizational problem. And in fact, most organizations, they don't want to change their organizations. You might see how agile is applied in most companies. It's like the old stuff, and then you have like scrums and whatever, but it's still the old stuff that gets like perpetuated over and over using a new vocabulary. And of course, the proponents of microservices, they say, hey, but you should use Conways Law. And basically, Conways Law says that your technical architecture mirrors your organization. And the picture, on the right side, there is this guy, it's me, is not very important. On the left side, however, it's Conways. So this is the guy who stated this law. So that guy is super famous, so I was super happy to have a picture with him. And those proponents say, yeah, you should revert Conway's law. So basically, you should change your organization to have microservices. However, if you look at organizations that really do microservices, like Netflix, for example, this is how they are organized. So basically, you have microservices team. You can call them two pizzas team, but it depends how much you want to eat pizza. But basically, it means that it's a small team, which is like a completely independent and self-sufficient. So you pick and choose a product manager, you pick and choose one guy from UX, some developers, some QA, some database administrator, depending on which technology you are actually using in this microservice, and then you assemble them, and then you have your microservice team. And the biggest problem with that is that this is probably how most companies are organized. I mean, this is what I've seen in nearly 20 years. So you have like silos everywhere, and all developers, they belong to the same silo, and all QA, they belong to the same silo, and all database administrators, they belong to the same silo. And what happens is basically to handle this silo, at the top, there is a manager. And the problem with microservices is that basically, if you are organized like that, then you don't need manager anymore, because as I mentioned before, those microservices team, they are self-sufficient. So if you are organized like that, it will be very, very hard to have microservices. And of course, there is also this stuff that many people look at the benefits of microservices and say, hey, I have this like not so great monolithical architecture, but all my problems come because it's a monolith. So I will change to microservices, and my life will be so much better. It will be all unicorns and rainbow. But actually, by going to the microservices way, you've got a lot more problems that you had before, because now you need to monitor even better. You need to be able to follow the flow of a request through your whole architecture, your whole microservices architecture. And so it requires a lot more maturity than ever before. So if you have a not so great monolith, perhaps the first pass would be like to make it better. And only then, if you need to go further, then migrate to microservices. So in this talk, I will try very hard not to talk about microservices, because as I mentioned, I believe that not a lot of people are doing that, but about web services, because yeah, I believe that a lot of people are doing web services, and probably REST web services, although some of you might still do like SOAP web services. So we have those web services, and we apply it Murphy's Law. And Murphy's law states that if something can go wrong, it will go wrong. So let's use this like simple UML diagram. As I mentioned, I was an architect before, so architects, we love this kind of simple diagrams. So we have a component A of type A that calls a component B of type B. And the problem with that is that it's on the whiteboard, it works super nicely. The problem with that is that on the whiteboard, it works super nicely, and it can be an API call, or it can be a microservice call. And if you just say, hey, from an API call to a service call, to a HTTP service call, is just an implementation detail, then you've got everything wrong, because as soon as you start using the network, well, you start having those little issues like, hey, the network is reliable. I mean, if you are going to go to the web service architecture, you probably know that the network is not reliable and latency is not zero, and well, and so on and so forth. So just say that, just focus on the first one, the network is reliable. So this is a sample web service architecture where I have like two clients that call a front web service. And in order to return the results, it calls a back web service. So when everything works fine, like client makes a request to F, F forwards the request to B, and everything is fine, and then it returns, and everybody is happy. Now imagine for some reason, something bad happens. As I mentioned, something bad will happen. And B might be down, or the network might be unreachable, there might be network partitioning or whatever. In the end, B is not available. So what happened is that C will make requests, and they will get stuck on the front web service that tries to call B, but because B is down, it will just die when the timeout is reached. And the problem is timeout takes a lot of time. So during that time, during the timeout, all requests that comes from clients to the front web service, they will just get stuck in a queue. And after a while, what happens is that F will die also. And that the biggest problem with like web service architectures, especially more so microservices, is that a very localized failure can propagate all over your architecture, so that in no time you killed all your architecture. And that's not what people want in general when they want to use web services. They want to be more resilient. They want to be more scalable. They just don't want that some like very, very far away and isolated web service kills everything. And now we have the circuit breaker pattern. And the circuit breaker pattern is just a way to handle the failure, just like you would do in a modern home to an electrical circuit breaker. So basically, if something happens, something won't happen in your home regarding the electricity, then the circuit breaker opens and the electricity stops. And here, we have a state machine that models the circuit breaker. So it starts at the beginning. And so the circuit breaker is closed and you make call and you are happy. And perhaps at some point there is one error, but it can happen. So as long as it's one error, the circuit breaker stays closed because one error is not an issue. You have one single timeout, but the queue still empties itself. But after a while, something happens, as I mentioned, and the service just dies. At that point, to prevent the error from propagating, we reach like a pre-configured threshold and we open the circuit breaker. And now every time we just try to call the service, it fails fast. So there is still failure, but at least the architecture is still resilient. Of course, if we stop at that, that means that once we reach the state where there is a failure, we cannot recover from it, which is not the truth. Sometimes the network comes back, the backend service, you kill it and you restart new instances. So the system might at some point get in better shape. So after some time, that can also be configured, you try to make a single call or perhaps two single calls. So we say that the circuit breaker is half open. If it works with a significant number of calls, then we can assume that the state is proper, and then we can resume our closed state and start like the beginning. However, if it fails again, we assume that it's still in a bad state and we still open the circuit breaker. And of course, you've got some configuration options. One configuration, how many fail calls do we need before opening the circuit breaker? And it can be like a certain number, or it can be a certain number in the sliding window of, I don't know, like 30 seconds or whatever. Another configuration is after we have this like open state, we try to close it again with the half open state. But how long should we wait? Should we always wait like the exact same number of attempts, or should we try to have like a dedicated time frame, like, hey, let's wait 5 minutes? And if it fails again, should we also wait 5 minutes, or should we double the time? Or, I mean, there are a number of possible options. And how many successful calls shall we make before we assume that, no, we are not half open, but we are completely closed now? However, there is one very, very important configuration option, and I think that's the most important one. And what do we do in the case of timeouts? Because the point is, first, let's not propagate the failure. Let's let our architecture be resilient. But the important stuff is what to do in the case of timeout. What results should we return? And at some point in my career, I used to work for an e-commerce web shop. And I like to have this e-commerce example. And I think it speaks to everyone. So I will take some examples, and for each service, we will see what can be returned. So we have a recommendation web service, like you probably have used on Amazon, like, hey, people who bought this also bought that. We have the pricing web service, like what we assume when we don't know about e-commerce is basically the price is fixed, but the price is actually very variable. It of course depends on the customer. It depends on whether the article is like liked or not. It depends on some like temporary promotions. It can depend on a lot of things. Then we have the permanent web service, and of course we want to log everything. So probably you have this centralized logging pattern. So there probably is a logging web service somewhere. So the logging web service is actually the easiest. It's just fire and forget. We just send the call to the web service, and it must probably be asynchronous, because if something is wrong, actually it doesn't break the architecture. We can still sell stuff, which is the most important. And we shouldn't do anything if something is wrong, just perhaps alert someone, and you probably already have like monitoring in place if the logging fails. Now the second one is much more interesting, the recombination service. We can assume that it's synchronous because we actually want the customer to see this in real time and not after 10 minutes after he finished his checkout. However, it's not really required. Like if we think about it, we can probably still sell without the recommendation service. So what should we return? Well, one easy way is if it's broken, we don't return nothing. We just return an empty set of recommended products, which is fine. Also, we could have like a static set of recommended product. It could be like hard-coded into the app, or it could be in the local database, or we can think about a lot of stuff. So what we should do, what exactly should be our strategy here? And as in most cases in projects, the answer is it depends, because that's not up to the developer or the technical people to decide what we should return. If it's broken, we should ask the business. So we should probably have like these nice metrics where we have like some options and pros and cons and probably like estimated costs. And then it's up to the business to decide, hey, yeah, we should return nothing because it's fine. We can live without any recommendation if the recommendation web service is broken. Oh yeah, but those are products are always like bestsellers, and we should always try to sell them whatever it takes. And then you can have static stuff. Pricing is a bit harder because here there is no option to actually return nothing. The point of e-commerce is to sell. Whatever it takes is to sell, to sell, to sell, to sell. So in general, the business will want to sell, and it's better to sell at a slightly outdated price than not to sell at all. So we could probably, in that case, have a cache. And as I mentioned before, you could use Hazelcast for that. So every time we get the price from the real web service, we should cache it. And if at some point the circuit breaker opens, then we should return the price from this cache. And then payment. Payment is the hardest because actually, there is no way to say, oh, let's cache stuff. So there are a couple of options though. We could accept like bad payments because again, we want to sell at all price. So we accept that among all those credit cost numbers, some of them might be wrong. Or we could devise some fallback saying, hey, our payments is right now down, but you will receive a mail in due time where you will be able to enter your payment details. So in that case, we will just like store all the orders and then like batch afterwards when the payment web service is back again. Then we should like batch email the customers, and then we should process them like that. You could also, like if you have like multiple payments, you can also send them invoices, for example. And depending on the country, it might work or not work. Like in Switzerland, for example, if you send an invoice to a customer and doesn't pay, you can like put them in, I don't know in English, it's called des poursuites. And basically it's a black mark on your credit status. And then afterwards you can have no credit, you cannot rent an apartment. It's going to make your life very hard. So in countries like Switzerland, sending an invoice and expecting people to pay after they receive the product works very well. In some other country, not so much. But there are a couple of options anyway. And from those four services that I've described, basically we can already see some trends, some typology that already appears. We can have the black box strategy that says, whatever happens, we just fail fast and we don't care that much because there is no really like any business logic involved. Or we can say, here we need some business logic. So we need to do some like code related stuff. And in that case, we must know what happens, and can only be implemented by libraries. So on one, like if you just see from the outside and you need to fail fast, then black box works, and then you have like proxies or service meshes. And if it's like from inside, then you have libraries. So on the service mesh side, you probably are familiar that right now Istio is a very, very strong contender in that space. And basically a service mesh like removes every responsibility of the application to do proxying, load balancing, service discovery, all that stuff is handled by the service mesh. So that your application that before had to do everything now is just a lightweight application, and you can focus on your work as a developer. The service mesh should handle that. So we have Istio that leverages Kubernetes. And Istio is just like an app called Envoy, which is a proxy. And basically what Istio does is every time you deploy a pod in Kubernetes, then you will deploy the Envoy proxy as a sidecar. So here, I don't have the, in general, I have a slide for that, but here I don't have it, sorry for that. So when I deploy a pod, when I deploy a container in the pod, if it's the first container in that pod, I will deploy the Envoy proxy. If I already have another container in the pod, I won't deploy it. And the magic of that is that everything is automated. So basically, there will be a listener on the Kubernetes API server. And then when Kubernetes will send an event, I will, well, not me, but Istio will check that it needs to create a new container under that pod. And from a bird's eye view, when such a sidecar is deployed, it will hijack all network communication. So when your container is deployed in the pod, now it doesn't communicate directly with outside the container. Everything must go through the Envoy proxy. And likewise, when it receives communication, then it also goes through the Envoy proxy. And the configuration is deadly simple. Basically, you have this destination rule, and then in this destination rule, you specify like some parameters, and basically you specify the number of consecutive errors. I was referring before the number of errors in the sliding window. So here there must be consecutive, and then the sliding window is 10 seconds. So here we have, if you have like 3 errors in a like sliding 10 seconds window, then you will open the circuit breaker. How long should the circuit breaker stay open until you try to close it again? And here we can see that the strategy is like fixed. You don't double the time, it's fixed strategy. And the last one is, I didn't mention it before because it's very Kubernetes specific, is basically you probably have a number of instances. You don't have one service with 1 instances, you probably have 1 service with n instances. And the reasoning behind this number is, in general, even if you have like 1 bad egg, you don't want to remove all your instances because in that case you have actually no service. But perhaps you want to keep some of them and hoping that something still works. And the problem, as I mentioned, is like Istio is fully black box. So basically you have no real fallback, you fail fast, but you return, well, nothing. So for logs, it's good. For the logging web service, it's good. And for the recommendation engine, when you say we return nothing, it's also good. Otherwise, not that great. And now you need to take action because I have actually, I can tell you about Hystrix or I can tell you about Resilience for J. The thing is that Hystrix is now it's maintained, but there will be no new release, and Resilience for J is like the next library to do that. So I will check the chat and see how you vote, and then I will do accordingly. Nobody wants to vote? Resilience for J, so I have 1 vote, 3 votes, okay. So it will be Resilience for J, which is good because as I mentioned, I will go to slide 44. and do Resilient4j. So it's inspired by Hystrix, but it's actually whereas Hystrix is object-oriented, Resilient4j is like completely functional in mind. Basically, it's all about function, wrapping function, and wrapping functions. No object orientation. There are a couple of features. So there is, of course, the circuit breaker. You can also have a rate limiter. You have retry. You have caching. You have a lot of different features. All those features, they come as like single jars. So if you want multiple features, you must like include them as jars in your application. And the good thing is that you get only what you want. If you only use the circuit breaker, you've got one jar. If you want multiple features, you've got as many jars as you need. As I told, everything is a function, and they use the concept of Java 8's functional interfaces, which basically is a supplier, meaning like, yeah, a supplier is a function that takes nothing as a parameter and returns something. And then you can compose those functions. And as a glue between them, you use a library called Vover, or I don't know, I heard recently someone call it differently. So I don't know how it's like pronounced. I call it Vover, but perhaps it's not right. And Vover is like how you can do functional programming in Java. So yes, you can already do some streams in Java, but really do function composition and like true functional programming. Those are bricks that are basically given to you. The problem with Resilient4j, in my opinion, is if you have been using Hystrix before or you are not used to functional programming, it's quite, I mean, it's not an easy step to make. So you first need to switch your mindset to like be a functional programmer, and afterwards it gets easier. But the first step it might be quite hard, and because we are inside the application, then we don't know, for example, how many instances of this service we have. So we have not big picture like we did in Istio. So everything that we can do must be resolved locally. And I have like a little demo for you, perhaps if you have some time. So here, I hope everybody sees my screen. Can you please, I have some feedback whether you can see my screen. So feedback comes. Yes, thank you very much. So I have two applications. I have like a pricing application. So this is specific to Spring Boot, but actually you can use whatever you want. I'm a Java guy, so I use this, but well, you can use whatever you want actually. And I have created like a simple application that basically just do the ask for quoting. So basically, it asks for quoting when you do the slash quotes, and it requires like a string. And afterwards, I have a like stupid like compute code from the string. And basically, I'm doing something that it's not random, but basically it will always be a bit different depending of some randomness, but it's actually based on the hash code of the string. So I want something that is not completely random, that is just like always stay a bit similar. And what I do, I also apply like some network stuff. And in that case, I simulate a failure. And this failure is after a certain number of calls, like which I call timeout grace counts, only one in X number of like 5, it will be 5, sorry, one call in 5 will be successful. Otherwise, I will just like have a timeout. So I created the application. So right now the grace count is 10 and the timeout is like 5 seconds, which is a lot. And then I get another application that will be calling this one, which I call, oh, sorry, Yes, this is one. Ah, yes. Sorry, I must also handle Zoom at the same time, which is not super funny. So I've created also an application, and this application basically is just like handle the service, and the service basically will get a product ID, and then we'll call the second service, the pricing service. And then here you can see how I handle the code with Resonance4j. So I must put everything into a completable future, which basically now becomes a supplier of a completable future. And after some point, I must say, hey, I have a timeout. So I handle the timeout myself. And then with this like timeout decoration, I handle it into a circuit breaker decoration. And then I'm using like Vover to have either like something that doesn't work, and then I will get the result from the cache, or something that works, and then I have the result from the service. And I return the result saying that, hey, it comes from the cache or the service, because I just want to see how it works. So I will start the pricing application. And because it's a reactive application, it starts very fast. And now I will start the shop application. Because it's a standard application, it starts less fast. As a caching backend, I have a simple Hazelcast instance, so nothing mind-blowing. And now what I can do, I can like try to shop. And so the shopping script does the following. It will just like non-endlessly call the shop endpoints, and just for every second. So normally after 10 calls, we should see that there should be an issue. And afterwards, we should see the circuit breaker. So here it's super fast because the quoting, the pricing service works, and it comes from the quoting service, because you see here origin is SRV. And now we see that it's slow and it comes from the cache, but it's very slow. Why? Because the circuit breaker is not open yet. And now it starts being fast again, because now the circuit breaker has been open, and now we don't even try to make the call to the service. We don't wait for 5 seconds. We just return the price that we have in the cache. And now we made a call, it worked again, so we've got this like price again. Yes, I see there is a question. So the question is why data in cache differs from each other. That's a very good question. The thing that happens is that basically you still have the call that is made. Where do I find it? Here, sorry. Whoop. So you still make the call, whether it fails or not. So at some point, you will still receive the result. And so basically, you will update the cache here. And even if you get into the, if you fall in timeout, you return fast, but still you get the result from the backend service. So this is a good question, because like under the cover, you update the cache. So thanks for your attention. You can read my blog. You can follow me on Twitter. More importantly, you have the source code for this application, so you can try like playing with it and playing with the parameters. And then there is like a full-fledged article that you can watch, that you can read, and you have all the talk in more detail. So I'm done, and perhaps now there might be some questions.
If anybody has questions, just feel free to write it down in the chat option.
Or if you are too shy, you can also DM me. My Twitter is open to direct messages. But the thing is that then only you will know the answer, because yeah, I can only answer like each person uniquely. So now if you want everybody to know more, you can ask questions publicly.
Great. Then I will just stop the recording.